And I brought you 12 secret insights, right? So don't tell anybody, it's a secret. First of all, like LLM, we're kind of, from my perspective, we're coming out of the LLM era. But training these models is still super hard. And I have a visualization that kind of maybe makes this more clear. On the left, you basically see what the model is doing, what training a model is like. So you're sampling a complex space, and you're trying to find an optimum. Here, in this case, it's one-dimensional, so super boring, right? And you can ask yourself, okay, I can sample like the kind of 1, 2, 3, 4, and then I see, oh, the optimum is somewhere between 2 and 3, and then I can sample in that region and increase that. And now you find the optimum, and it's like all pretty calm. What is necessary? What capability? What properties of this function are necessary for this to work? Well, and it's necessary that it's kind of stable in a sense, right? If this kind of curve would be all over the place and would be constantly iterating between like -10 and 10, this kind of sampling would get you nowhere. And on the right-hand side, and this will begin to move in a second, you will see the stable and unstable regions training large LLMs. And so now we're zooming in, and what you need to see is that these regions are calm. Right? So that there is a clear gradient, so you can know, okay, it gets better in that direction, this region is stable, this region is unstable, and now we're zooming in, and basically these colors are the difference between stable and unstable training runs. Now we're zooming in, and the smaller we get, the more we zoom in, the tinier the differences in parameters get. So eventually, when we are fully zoomed in, the difference between one block and the other is like 0.0000001 different in parameters. And that's the reason why even the best people, even the best labs, they struggle to get predictable results. And so they're still starting tons of runs in parallel, because this is a super wild, and this is just like a simplified visualization of high-dimensional space, right? So basically, this is basically what's happening. And now basically we're at the grid level. So this is what makes this so super unstable. We also kind of stopped the scaling mania, right? So we basically, when you think a few years back, everyone's like bigger and bigger, right? We just need the biggest piles of GPUs. How many parameters? The first question the press was asking how many parameters has this model? And nobody's really asking that question anymore. But I found basically from 2023, from a presentation I gave from our multimodal model, a nice reminder of that. And this is, you see here, 64 GPUs. So this is like tiny from today's perspective. But if you basically ask our multimodal model that's trained on 64 GPUs, if this cat were elected, its first order of business would be 2, then the small model would say, make sure the economy is strong. And then which is a very presidential answer, it's all fine, but if you train the model bigger, it kind of says, declare war on the dog. So basically, the more these models train, and this is like a combination of size and iterations and compute, the more they pick up on the maybe humorous context and kind of be able to give you a meaningful answer. But we kind of stopped there in the sense that we are still spending tons of compute, but we're not on the race of building bigger and bigger and bigger and bigger models. We also found that these models seem to not really generalize. Right? So basically, this was the same presentation, basically, where we basically said, well, we know that we cannot really get auto distribution of our training data, so let's put everything in distribution. And this is what's happening. People are spending billions on data. People are trying to make the models better by not making them more powerful to think by themselves, but to just give them more patterns to memorize. And this kind of works. But when you go into deep industry problems, the problem is that this data is not like available easily. Right? People are paying $60, I've seen $80 for an answer to a single question, just because the person that supposedly answered that question has a bare level understanding of maybe legal context, right? This is like crazy. When you think about an industry player, the kind of highly specific knowledge they need on their shop floor or in their research, right? Like this is not easily achievable. So it seems like LLMs alone may not get us to AGI. There are people who disagree, but more and more people, I mean, Jan was one of, I mean, Gary Marcus, right? I'm not sure, if he's probably not around, but he was kind of one of the first people to talk about that. Jan talked about that. But basically, there is this kind of sentiment that if we want to do like truly groundbreaking AGI, basically the vision many have started with, just building LLMs may not be the way to go for that. Okay, and maybe for that reason, but the business model around LLMs is still kind of difficult. And this has to do with like state-sponsored open source. This has to do with strategic interests, like geopolitical interests, strategic interests of trillion-dollar companies, where they can afford to not care about the unit economics of an LLM. So it's a market that is not what we would call a functioning market, but it's basically a vehicle where geopolitics plays out, where trillion-dollar companies basically forge alliances and build their ecosystems. So basically, what Sifted wrote here, or how they quoted me, just having an LLM is not sufficient as a business model. I would say that still kind of holds. Like, I'm not saying that you cannot build like a super specialized thing and maybe be successful with that, but it's difficult. Because open source is progressing so fast and this stuff is for free. Right? The money actually spent by DeepSeek R1 is, of course, not 5 million. It's like more 2 billion. And it's for free. So the question that so when we started in 2019, and the first question was always, what's the best LLM? Right? I want the best LLM. Do you have the best LLM? Do you have the best LLM? Right? I'm not being asked that question anymore. People are deciding for ecosystems. If I had the best LLM in the world, and I would just have that, and I would give that to an enterprise, they would have a lot of trouble putting that into production. Because you need scaling, you need data connection, you need to connect it to tools and to systems, you need to filter, you need to, like all this kind of stuff around the LLM that's making it powerful. And you may have seen that in the news just like the recent days, that the performance for some models suddenly fell off a cliff. So you are paying for the same model, it has the same name, and you basically get worse results. Because you're not paying for a model, you're paying for a product. And that product eventually maybe uses an LLM or uses caching, or GPT-5 famously being called the router because it tries to route your request to the cheapest way to fulfill that request. And of course, this makes tons of business sense. But it means that we are kind of moving in that direction where we now have the infrastructure consolidating, we now have the general intelligence capabilities consolidating into ecosystems. Another reason why so many production, like POCs cannot be put into production or enterprises fail is, if we are building with LLMs, we are building with a fundamentally new paradigm. Because these systems are not deterministic. They're stochastic systems. So they give you an answer if you query an API, but if you do it 5 times, you get different answers. And these different answers maybe, they all have value. Right? It's not like one is truly correct and the others are rubbish. Like there's different perspectives maybe in there. And this is, by the way, this is a picture from my thesis, where I was building Bayes networks. It's a different thing, right? But the cool thing about Bayes networks is that it thinks about every single node in a network has not a single value, but a probability distribution over values. And so like every single fact, every single knowledge can be all kinds of things. And they all have interdependencies. So if I read this paragraph that way, then this has consequences for how the next page is to be understood. Like these crazy stochastic interdependencies, they're not easy to build. And the way we've built software so far was not like that. It was like easy. Maybe the code had a bug, sure. But eventually, it had a deterministic outcome, and we could test against that. And we cannot easily with stochastic systems. And this is basically, Peter said this brilliantly, we cannot do it alone. Right? Like, even the trillion-dollar companies, and you've seen the charts showcasing that, they are forging alliances and they're leveraging each other's advantages to get on top. And nobody should think that they can do it by themselves. Right? This is such a fundamental change in how the world works. There's so much at stake, geopolitically, financially, our safety is at stake. And we should not fool ourselves and basically go at it with that mindset, oh, it's like, this is my piece of the cake, and this is your piece of the cake. Don't do that. There's also this strategy, the European strategy, the German strategy, our industrial policy. I think this frustrated me here and there, and you will maybe see why. So there's two strategies really you can do. There's a pioneer strategy, meaning that I want to be the first, I want to be the strongest. At every crosswalk, I decide towards power, towards growth. That's relatively easy to execute, so it gets like a medium difficulty rating. And the only thing you're compromising is maybe a little bit of resilience, right? Because things, if you're over-leveraged, if you're exposing yourself, things can go wrong. You can also try the Guardian strategy. Say, resiliency first, safety first, but you cannot do this without selected fields where you want to be strong. Because if you do that without being strong, then the resources to enact your Guardian strategy will dwindle. You will have no kind of dry gunpowder, you will have no kind of experts, everybody will be gone, right? And so your ambition for safety is moot, because you cannot enact it. I think that's a valid strategy, but it's more difficult, because you have to balance two competing interests. You can also try to do something like a compromise or like meandering around where you're not really achieving either goal. So neither are you achieving any like safety or right, nor are you going to become strong. And when you think about the effect we had for like Europe and our strategies, I would argue we are sometimes on the right side. We're doing a lot of stuff. We're pulling a lot of resources. We are slowing everything down. And in the end, we're not really achieving anything other than keeping ourselves busy, maybe. And I think this is dangerous. Don't do that. Work is changing super fast. This is the job market, compare junior employees with senior employees. You may have seen these numbers. And there's a new category called work slop. I have two phenomenal quotes for you. Employees are using AI tools to create low-effort, passable-looking work that ends up creating more work for their coworkers. And I like what the director of retail said. I had to waste more time following up with the information and checking it with my own research. I then had to waste even more time setting up meetings with other supervisors to address the issue. Then I continued to waste my time having to redo the work myself. So this is basically what AI is causing in knowledge work currently, work slop, right? So we need a new way to engage with humans, to make humans, give humans the power to use their knowledge and their experience, right? Because, okay, maybe one machine can do the work of 50 ordinary men, but no machine can do the work of an extraordinary man. And we need to build for that. The human, the expert, is not just the user that writes the prompt. We need a new paradigm for human-machine collaboration. And of course, there's also other developments like robotics, and so AI is now creeping into all the fields. This is like a Munich startup, and I'm helping out. They are using robotics for care, which I think is one of the biggest responsibilities we have with like the dwindling demographics. Phenomenal company, but this is like on every space. But it's difficult for Europe, right? So this is the submissions for the last Europe's conference spread down by kind of affiliation. And so Europe is the screen part over here. And when you look at who is that, well, this is Oxford, okay? EPFL, ETH, and technical university, you know what that is, right? But these are super small numbers. And of course, this is just this Europe's, and we contributed tons of phenomenal papers that I clear, so it looks a little bit different on different conferences, but this looks dire. So I think Europe is, we used to be so brilliant at research, and I think we are losing that spark, and we're losing that spark because the industry partners are missing. In today's AI world, academia cannot do it by themselves. They have brilliant talent, they have brilliant professors, they cannot do it by themselves. And we are just, in Europe, we're missing the companies that can do what a Google can do, what a Meta can do, what, of course, the Chinese can do. And so this really worries me for the future of Europe. But there are also strong opportunities and friends also out of Europe. And I'm talking internationally. There's a lot of people that wish for a strong Europe, that want to ally with us. And I want to remind you, finish by reminding you of one of the situations where Europe also was almost over. This was 1683. Vienna was at the breaking point. After 2 months of siege, the walls were shattered. The fall of the city seems inevitable. If Vienna falls, this would have been the end for the Europe we now live in. But on the surrounding heights of the Kahlenberg, a different fate gathers. For the first time, a coalition of nations stands together. The morning sun catches the steel of a massive relief army. And the ground begins to shake, and the Lion of Lechistan, King Jan III Sobieski of the Polish-Lithuanian Commonwealth, leads the winged hussars in the largest cavalry charge in history. The momentum of the world shifts in a single afternoon. The tide has turned. So there are friends around, but we need your help. Like, your actions will make this future. And if I can help, disclaimer, I'm pretty busy, but if I can help, send me an email. I'm happy to do that. All right, have fun, enjoy the conference.